How far is the distance from Earth to the Sun? The distance from Earth to the Sun is 149,597,870,700 meters, 149.6 million kilometers. Astronomers use a unit of measurement called an astronomical unit, O, to measure distances between celestial bodies in the solar system. An AU is defined as the distance from Earth to the Sun, which is approximately 149,597,870,700 meters, 149.6 million kilometers. The O is used by astronomers to measure the distances between objects within the solar system. For example, the distance from the Sun to Mercury is about 0.39 astronomical units, while Neptune is about 30.07 astronomical units away from the Sun. At the outer edge of the solar system lies the Oort cloud, believed to be the birthplace of comets, which is located 100,000 astronomical units from the Sun. The distance to the nearest star, Proxima Centauri, is approximately 250,000 astronomical units. However, for measuring distances beyond that, astronomers use the concept of light years, which is the distance light travels in 1 year. 1 light-year is equivalent to about 63,239 astronomical units. Therefore, in light-years, Proxima Centauri is located about 4.2 light-years away from the Sun. However, as you may already know, the Earth's orbit around the Sun is not a perfect circle. It is an ellipse. Therefore, during a year, there are times when the Earth gets closer to the Sun and times when it moves farther away. The point on the orbit where the Earth is closest to the Sun is called the perihelion. The distance at this point is approximately 146 million kilometers, and Earth reaches this point in January every year. The point on the orbit where the Earth is farthest from the Sun is called the aphelion. The distance at this point is approximately 152 million kilometers, and Earth reaches this point in July every year. In recorded history, the Greek astronomer and mathematician Aristarchus of Samos was the first person to measure the distance from the Earth to the Sun around 250 BC. In modern times, the Dutch astronomer Christiaan Huygens measured the distance from the Earth to the Sun in 1653. Mr. Huygens utilized the phases of Venus to search for angles within the triangle formed by Venus, Earth, and the Sun. For example, when Venus appeared half illuminated while the Sun was shining, the three celestial bodies formed an isosceles triangle as observed from Earth. By estimating the size of Venus, coincidentally but accurately, Mr. Huygens could determine the distance from Venus to Earth. With this known distance, along with the angles of the triangle, he was able to measure the distance to the Sun. However, since Huygens' method partly relied on inference and was not entirely based on scientific principles, it was not considered reliable. In 1672, the Italian mathematician and astronomer Giovanni Cassini employed a method that included parallax, or angular displacement, to determine the distance to Mars and simultaneously calculate the distance to the Sun. He sent a colleague named Jean Richer to the French Guiana region while he himself remained in Paris. They measured the relative positions of Mars with respect to other stars and created a triangulation grid using the measured results along with the known distance between Paris and Guiana. Once they obtained the distance to Mars, they could also calculate the distance to the Sun. Due to the more scientific nature of Cassini's methods, they were considered reliable. With the advent of spacecraft and radar, humans have had the means to directly measure the distance between Earth and the Sun. The definition of the astronomical unit, O, used to be the radius of a circular, unperturbed orbit around the Sun of a particle of infinitesimal mass, moving with an average motion of 0.017202099895 radians per day, known as the Gaussian constant. Aside from making things unnecessarily difficult for astronomers, the above definition is not compatible with the theory of relativity in general. Using the old definition, the value of the O would change depending on the observer's position within the solar system. If an observer were on Mercury and used the old definition to calculate the distance between Earth and the Sun, the result would deviate from the computed value on Earth by about 1,000 meters. Furthermore, the Gaussian constant depends on the mass of the Sun, and since the Sun loses mass as it radiates energy, the value of the O changes along with it. In August 2012, the International Astronomical Union (IAU) officially confirmed the value of 149,597,870,700 meters for one astronomical unit. This value is based on the speed of light, a defined constant. 1 meter is defined as the distance that light travels in a vacuum in 1/299,792,458 of a second.